Welcome back to structural dynamics. Today we will see how to formulate a equation of motion. Like equilibrium equation in statics, we also have some dynamic equation of motion. Okay, those depends on some particular equations. We will see those how we can solve those, formulate those equilibrium of equation. Okay, we will see how to formulate the equation of motions. Okay, this equation of equilibriums can be formulated by using different type of mathematical expressions. We can see here the mathematical expressions defining the dynamic displacements are called the equation of motion of the structure, and the solution of this equation of motion provides the required displacement time histories. These all are provides required displacement time histories. It indicates the amplitude of the body with respect to time during the force, whereas dynamic force is the force which is vary with respect to time. Okay, those during that force there will be, we can see some displacement of the body which can indicates the amplitude of the body. Okay, and those relation between those amplitude with respect to time we used to call as the time history data. Like we used to have time displacement time history, velocity time history, as well as acceleration time history diagrams. To formulate the equation of dynamics, we used to use Newton's second law, where we can see here, this law states that the net force on an object is equal to the rate of change of its linear momentum, indicated by small p, in an inertial reference frame. If you take any frame, any body, the force F is equal to the rate of change of momentum, where p is the momentum of the material. You can see here force is equal to dou p by dou t, dp by dt, which is nothing but d of p indicates the momentum, which is nothing but mass related with the velocity. Body is moving with the velocity v, indicates the momentum, the rate of change of the momentum, which is nothing but force. Whereas here we see the mass will be the constant. In this case mass will be constant. If you take this one is outside, we can get dv by dt, whereas the rate of change of velocity, which is nothing but mass into acceleration, and F is the net force applied over the body, and m is the mass of the body, a is the acceleration of the body. This is regarding the Newton's second law in dynamics. Similarly, we have another equation. If you see here, what do the physics tells about magnitude of the force that different type of buildings feels during an earthquake? When we apply the ground excitation in this direction, ground acceleration of the body in this direction, body will be moved in opposite direction. Okay, the moment, the inertial force will be generated in this body. Okay, this is regarding mass, regarding the force in the during the earthquake, or force during dynamic excitation. Similarly, we have another equation to solve the equation of dynamics. The body, we used to use this D'Alembert's principle. Here we can see the body is in equilibrium under the action of the real force F and the fictitious force M, whereas real force indicates the ground excitation or ground motion of the body, whereas MA indicates the excitation of the body when the body is tilting or falling in opposite direction or moving in opposite direction, will be indicate the fictitious force. Okay, that is related with the inertial force, mass into acceleration, and that fictitious is also called as the inertial force and is reversed effective force, means the effect will be in reverse direction. If you apply the ground excitation in one direction, positive direction, the moment of inertial force will be generated in opposite direction. in reversal direction. And we can get the equation like this: F minus ma is equal to 0, which is the D'Alembert's equation, and F is known as the inertial force created by the building's tendency to remain at rest. Building tendency is nothing but mass into acceleration generated by the building in its original position, although the ground beneath is its movement. There may be some motions under the ground, but motions of the body will be there, but body will be remain stable. It remains in original position. There won't be any deflection in the body. That one represented by the D'Alembert's principle. Okay, and this particular equation indicates this particular equation condition. Here we can see engineering representation of the earthquake force. When we apply the earthquake force, body will be in rest condition only. There won't be any deflections like this. Okay, this is regarding D'Alembert principle, and you can see here direct equilibrium equilibration of using D'Alembert's principle. The equation generated using D'Alembert's principle. The equation of motion of any dynamic system represents expression of Newton's second law of motion, which states that the rate of change of momentum mv of any mass particle m is equal to the force f of t acting on it, whereas f of t is nothing but rate of change of momentum m into dou v by dou t, whereas v of t is represents the position vector of the particle. Every mass will be having the velocity here, and thus velocity indicates the direction of the force or position of the vector, the body mass. Mass does not vary with time, but it can change the location. Okay, that's why we used to take f of t is equal to mass as constant and remaining body we used to take as the acceleration. Rate of change of velocity is called as the acceleration, whereas final equation we used to get m into u double dot of t, whereas u double dot of t indicates the acceleration of the body. The above equation indicating that force is equal to the product of the mass and the acceleration. You can see here f of t is minus m dot into acceleration u double dot of t is equal to 0. This equation is used to call as the equation of dynamics. And everywhere to solve the dynamic equilibrium equations, we used to use this equation. Depending on this equation, we used to solve the many more problems. And the second term, mu double dot of t, is called as the inertial force resisting the acceleration of the mass. The force which is resisting the acceleration of the mass. The concept that a mass develops an inertial force proportional to its acceleration. Okay, the inertial force will be directly proportional to the acceleration, and opposite to it is known as a D'Alembert, opposite to location direction, and it is in opposing direction is known as the D'Alembert's principle. Okay, this is regarding the D'Alembert's principle. With this I am stopping. In the next lecture we will see regarding principle of virtual displacements. Okay, thank you.